All right, welcome to the Explainer. Today, we're diving deep into OpenAI's newest and pretty big move, the release of some powerful new open-weight models they're calling GPT-OSS. We're going to get into what makes them tick, and more importantly, why they could be a real game changer for everyone.
You know, the entire world of AI is kind of wrestling with this one massive question. When you make powerful technology open source, are you just handing power to the people, or are you accidentally giving a loaded weapon to bad actors? It's this huge tension that sits right at the heart of what we're talking about today.
So, what's OpenAI's answer to this huge challenge? Well, they're rolling out something they're calling a new kind of OpenAI.
So let's meet them, GPT-OSS 120B and its little brother GPT-OSS 20B. Now, these aren't just your average open models, they're specifically open-weight reasoning models. That means the keys to the kingdom, the core model parameters, are being released for anyone to use. They're designed from the ground up to be incredibly powerful, but also, and this is the key part, responsibly released.
So what can these things actually do? Well, they're built for the heavy lifting. Complex reasoning, tough problem solving. They can follow really detailed instructions and even use tools like searching the web or writing Python code. But the really cool part for developers is that they're fully customizable. And maybe most importantly, you get the model's full chain of thought, so you can see exactly how it got to an answer, not just the answer itself. Okay, so how on earth did they build something this powerful, but also efficient enough to actually release to everybody? What's the secret sauce here? The first big ingredient is this thing called mixture of experts, or MOE for short. And honestly, the best way to get your head around it is to imagine a huge team of specialist consultants. You've got your math expert, your history expert, your coding expert. Instead of the whole team weighing in on every single problem, the model is smart enough to just call on these specific experts it needs for that one task. And that right there makes it unbelievably efficient. And this efficiency, it's just wild when you look at the actual numbers. The big model has over 116 billion parameters in total, a massive number. But because of that clever MOE system, it only actually uses about 5.1 billion of them for any single task. That's the magic trick. That's what lets this absolute powerhouse of a model run on just a single high-end GPU. And the other cool trick they've got is something called variable effort reasoning. What this means is that you, the developer, can basically tell the model what to do. You can say, hey, this is a really tough problem. I need you to think harder. And it'll spend more time and get more accurate. Or for simple stuff, you can tell it, think faster, and it'll save you time and money. It gives you total control over that balance between performance and cost. Okay, so that's all the cool tech under the hood. But the million-dollar question is it any good? Like, how well does it actually perform when the rubber meets the road? Let's take a look.
So when you put it to the test on some really tough benchmarks, GPT-OSS 120B, well, it's a real powerhouse. We're talking about things like super hard competition math, PhD-level science questions, and complex coding challenges. And as you can see, it gets impressively close to the performance of the very best closed models, like OpenAI's own o4 Mini. This is not a toy, it's a serious tool.
But where things get really interesting, maybe even a little mind-blowing, is on HealthBench. This isn't just a multiple-choice test. It's a benchmark that simulates complex back-and-forth medical conversations. And here, the 12B model is right up there, competing with the absolute best, most expensive closed models. That is a massive step towards making high-level health intelligence way more accessible to everyone. And don't just take my word for it. The researchers themselves put it this way. They said, these results represent a large Pareto improvement in the health performance cost frontier. Now, Pareto improvement is a fancy term, but what it boils down to is this. You're getting world-class performance for a tiny fraction of the cost. And in a field like healthcare, that's potentially transformative. But you know the saying, with great power comes great responsibility, right? And that brings us to maybe the most important part of this whole story, the ultimate safety test. So this leads us right to the elephant in the room. With all this reasoning power now out in the open, what's stopping a bad guy from taking it and fine-tuning it to do something awful? Well, to figure that out, OpenAI's safety team did something pretty cool. They didn't just cross their fingers and hope for the best. Nope, they basically decided to become the bad guy. They took their own model and threw all their expertise and resources at it to try and break it, to specifically make it better at doing harmful things. They called this process the adversarial gauntlet, and it's this really clear, systematic approach. Step 1, you ask the big question, can this thing even be made dangerous? Step 2, you pretend you're an attacker with all the money and know-how in the world. Step 3, you actually go and fine-tune the model to be good at harmful skills. And then, the final step, you test that new dangerous version to see what damage it can actually do. And they didn't just test random stuff. They focused their attack on two of the absolute biggest fears in AI safety right now. First, biorisk. Could this model help someone get the information they need to create some kind of biological weapon? And second, cybersecurity. Could it be used to automate hacking or find brand new security holes?
Okay, so after putting their own model through the ringer, after trying their best to break it, what did they find? What was the final verdict on the risk? Let's look at biorisk first. That purple bar you see, that's GPT-OSS after the team did their worst to it. Now, look at the orange bars. Those are other powerful open models that are already out there, and the story is crystal clear. Even after they intentionally tried to make it dangerous, the model did not get significantly better at these harmful tasks. It didn't raise the danger level.
And on the cybersecurity side of things, same story. They ran it through these capture-the-flag style hacking competitions. The malicious, fine-tuned version of the model, it performed about the same as other models that already exist. And critically, it never crossed the line into what OpenAI considers a high risk. So let's just boil it all down. Could they make it truly dangerous? The answer was no. Even after they tried their hardest, it never reached high-risk levels. Did it raise the bar for what a bad guy could do? Again, no. Its abilities were still in the same ballpark as models that are already available. The bottom line is, this release doesn't seem to be creating some new, scary level of danger. So when you zoom out, what's the big takeaway here? It's not just about a cool new model. It's really about creating a new blueprint, a new standard for how you evaluate and release this kind of powerful AI out into the world openly and responsibly. And that really leaves us with one big, thought-provoking question for the future. Is this kind of intense what-if testing, where you try to break your own stuff before anyone else can, is that the future of responsible AI? OpenAI is making a pretty big bet that it is. Thanks for watching The Explainer.